Section 1. Introduction. Machines are everywhere. From the simplest doorknob to the most complex spacecraft, machines make our lives easier and more productive. They are tools that help us do work by changing the direction or magnitude of force. We use machines to move heavy objects, transport ourselves, and even explore the universe. But have you ever stopped to think about how these incredible inventions actually work? In this essay, we'll embark on a journey to uncover the secrets of machines, both simple and complex. We'll explore the fundamental principles that govern their operation and delve into the various types of machines that shape our world. Get ready to be amazed by the ingenuity of human invention and the power of simple mechanics. Our exploration will begin with the basic building blocks of all machines, simple machines. We'll then move on to more complex machines, understanding how these simple components are combined to create sophisticated tools. Along the way, we'll discuss key concepts like work, efficiency, and mechanical advantage. So buckle up and get ready for a fascinating adventure into the world of machines. Whether you're a budding engineer or simply curious about how things work, this essay will provide you with a deeper understanding of the mechanical marvels that surround us. Section 2. What is a machine? A machine is any device that helps us do work. It can be as simple as a lever or as complex as a car engine. Machines work by changing the magnitude or direction of a force. They can make work easier by allowing us to apply less force over a greater distance or by changing the direction of the force we apply. Machines are categorized into two main types: simple machines and complex machines. Simple machines are the most basic forms of machines, consisting of only a few parts. They form the foundation for more complex machines. Examples of simple machines include levers, pulleys, wheels and axles, inclined planes, wedges, and screws. Complex machines are made up of multiple simple machines working together. They perform more intricate tasks and often involve a greater number of moving parts. Examples of complex machines include bicycles, cars, airplanes, and computers. Despite their complexity, these machines still rely on the fundamental principles of simple machines to function. Section 3. Simple machines. The building blocks of complexity. Simple machines are the fundamental building blocks of all mechanical devices. They are characterized by their simplicity, consisting of only a few parts. Yet, despite their basic design, simple machines are incredibly versatile and powerful tools. They can be used individually to perform a wide range of tasks, or combined to create complex machines capable of even greater feats. Each type of simple machine operates on a unique principle, utilizing specific mechanical advantages to make work easier. For instance, levers help us move heavy objects by multiplying the force we apply. Pulleys allow us to lift objects with less effort by changing the direction of force. Wheels and axles facilitate movement by reducing friction, enabling smooth rolling motion. Inclined planes make it easier to move objects upward by spreading the force over a longer distance. Wedges are used for splitting or separating objects, while screws convert rotational motion into linear motion, making them ideal for fastening objects together. Understanding simple machines is crucial for comprehending the workings of complex machines. By studying these basic components, we can decipher the intricate mechanisms of more sophisticated devices. In the following sections, we'll delve into each type of simple machine in detail, exploring its unique characteristics and real-world applications. Section 4. Levers, moving the world around us. Levers are one of the most common and versatile simple machines. They consist of a rigid bar that pivots around a fixed point called a fulcrum. Levers come in three classes, each defined by the relative positions of the fulcrum, the effort, the force you apply, and the load, the object you want to move. A first-class lever has the fulcrum positioned between the effort and the load. Examples include seesaws, crowbars, and pliers. Second-class levers have the load situated between the fulcrum and the effort, as seen in wheelbarrows and nutcrackers. Third-class levers have the effort placed between the fulcrum and the load, like in tweezers and fishing rods. Levers make work easier by allowing us to apply less force over a greater distance to move a heavier object. The mechanical advantage of a lever is determined by the ratio of the distance from the fulcrum to the effort, and the distance from the fulcrum to the load. Longer levers provide a greater mechanical advantage, making it easier to move heavy objects. Section 5. Pulleys, lifting with less effort. Pulleys are another ingenious simple machine that makes lifting heavy objects easier. They consist of a grooved wheel with a rope or cable running along the groove. Pulleys can be used singly or in combination to create systems with varying mechanical advantages. A single fixed pulley simply changes the direction of the force required to lift an object. It doesn't provide a mechanical advantage in terms of reducing the force needed, but it can make lifting more convenient by allowing you to pull down instead of up. A movable pulley, on the other hand, does provide a mechanical advantage. By attaching the pulley to the object being lifted and anchoring the rope to a fixed point, you can reduce the force required to lift the object by half. Multiple pulleys can be combined to create complex pulley systems, such as block and tackle systems. These systems offer significant mechanical advantages, allowing you to lift extremely heavy objects with relatively little effort. Section 6. Wheels and axles, rolling to success. Wheels and axles are essential components of countless machines, from cars and bicycles to conveyor belts and windmills. This simple machine consists of a wheel attached to a smaller cylindrical rod called an axle. The wheel rotates around the axle, reducing friction and enabling smooth movement. The mechanical advantage of a wheel and axle system depends on the relative sizes of the wheel and the axle. A larger wheel relative to the axle provides a greater mechanical advantage, making it easier to move or rotate a load. For example, a steering wheel with a larger diameter makes it easier to turn a car's wheels. Wheels and axles are used in a variety of applications, including transportation, manufacturing, and power generation. They are essential for moving loads efficiently and reducing the effort required to overcome friction. Inclined planes, also known as ramps, are another type of simple machine that makes moving objects easier. They consist of a sloping surface that connects a lower level to a higher level. Inclined planes make it easier to move objects upward by reducing the force required, but at the cost of increasing the distance over which the force must be applied. The mechanical advantage of an inclined plane is determined by the ratio of the length of the slope to the height of the incline. A longer, less steep incline provides a greater mechanical advantage, requiring less force to move an object up the ramp. Examples of inclined planes include ramps for wheelchairs, loading docks, and even staircases. Inclined planes are commonly used in construction, transportation, and everyday life to move heavy objects with less effort. They are a simple yet effective way to overcome the force of gravity. Work, in the scientific sense, refers to the application of force over a distance. When we use a machine, we input work to get a desired output. Work input is the work we do on the machine, while work output is the work the machine does on the load. Ideally, the work output of a machine would equal the work input. However, in reality, some energy is always lost due to friction and other factors. This means that the work output of a machine is always less than the work input. Understanding the concept of work input and output is crucial for evaluating the efficiency of a machine. By comparing the work input to the work output, we can determine how effectively a machine converts our effort into useful work. Machine efficiency is a measure of how effectively a machine converts work input into work output. It is expressed as a percentage, calculated by dividing the work output by the work input and multiplying by 100. No machine is 100% efficient. Some energy is always lost due to friction between moving parts, air resistance, and other factors. This means that the work output of a machine is always less than the work input. Improving machine efficiency is a constant pursuit in engineering. By reducing friction, optimizing designs, and using better materials, engineers strive to create machines that maximize work output while minimizing energy loss. Understanding machine efficiency helps us make informed decisions about the tools we use. By choosing machines with higher efficiency, we can reduce energy consumption, save money, and minimize environmental impact. Machines, in their various forms, are essential tools that shape our world. From simple levers to complex engines, machines make work easier, enhance productivity, and enable us to achieve incredible feats. By understanding the fundamental principles of machines, we can appreciate the ingenuity of human invention and the power of simple mechanics. We've explored the key concepts of work input and output, machine efficiency, and the different types of simple machines. We've also seen how these simple components are combined to create complex machines that perform intricate tasks. As we continue to innovate and develop new technologies, our understanding of machine mechanics will remain crucial. By harnessing the power of machines, we can unlock new possibilities, solve complex problems, and continue to advance human progress. So the next time you encounter a machine, take a moment to appreciate the intricate workings that make it all possible.